off Chapter 7 in Let Over Lambda. There's a couple of topics in here that was very interesting to me, just because I'm coming from a C++ background, and C and C++ background. Specifically, the first topic that we're going to be discussing today on simulating pointers, as Hoyt likes to call it. He found a particular paper called Schematics of, or it was, I think it was a book called Schematics of Computation. The author of this particular technique, Oleg Kislov, figured out a way of leveraging closures as a way of actually giving some notion of, pointer indirection inside Lisp. Now, he wrote it in his particular in the paper has an implementation in Scheme. But today we're going to be discussing, obviously, how you could, sort of do the same idea with Common Lisp. Now, one topic I wanted to bring up, sort of to start, kind of like some discussion on this is first a question: how familiar are folks with just pointers in general in manual memory management in languages? The folks that are currently on the Jitsi Hangout.
Yeah.
Go ahead.
I'm somewhat familiar. I mean, I'm not a C guy by any means. I hardly have any C experience at all, but I just, pass by reference.
So the basic idea of pointers in C is you have this entire fixed address space, of memory locations. Usually, each memory location is the size of like a fixed num in Common Lisp. And C allows you to kind of, be able to directly access each of those, indexable memory locations through this data structure called a pointer that just keeps track of the memory address that you could dereference and then provide, content into that particular memory address. But again, it has to be a size of fixed num. If you're going to be doing larger than that, obviously you need to allocate to the stack memory and be able to allocate.
Can I interrupt you for a second?
Yeah, sure.
Just meta talk for a minute. For those who just joined the stream, we're using a new platform now, and if you click on your name on the upper right-hand corner of your screen, you can change your name. I see we have a couple of default usernames. It's going to be hard to address you if you have a problem. No, just some info to let you know about. Thanks.
That's a good point. I should have mentioned that. Yeah, Jitsi is going to be our platform moving forward now. It actually turned out to be really useful, especially when it came to handling things like encoding, because we had a couple of comments about our encoding in the past. Hopefully, at least from the last stream, it looks like some of those have been resolved. Although there's still this issue with 720p. That's actually kind of Jitsi's doing its encoding through whatever it's using to do still 720p HD, but it still looks much better than some of our earlier streams. So if you guys have comments on that, please let me know. Please let Michael Fiano know, or DJs when on the Discord, and we can.
He'll be a little late, but he should be here.
Yeah, and it'll be fine. So to start things off, I went ahead and implemented the kind of his pointer macros. Now, for folks who haven't actually gone through, or it's been a while since you've seen some of the earlier videos, just to give you kind of a fair warning, this isn't at all. I ported this code from Hoyt's book because Hoyt uses his own little notation, specifically the def macro bang. That's his macro. I'm not using that at all in our examples. So if you're looking at the book and you're wondering why isn't there like a bang, or he's not using like G bang or O bang for some of the symbols, it's because I'm trying to do this in as vanilla Common Lisp as possible so that it should just work without having those additional utilities. So to simulate pointers actually turns out to be just 4 simple functions. Well, 3 functions and a macro. You have the pointer ampersand, which is really simulating creating a closure, a fixed location of some value that you want to kind of wrap around. And it goes in and returns you an actual closured object around that value or that reference in memory that you're trying to manipulate. And it's a fixed location so that you're using the closure and the ability to like set and get from the closure to actually go and access this memory location. Now you can see an example of this usage here on line 25, where I basically tried to simulate, double indirection inside Common Lisp. What this does is creates a closure within a closure that you then need to dereference using the pointer star function that he has to actually access that memory location. So let's see how this kind of works. Hopefully, I didn't probably compile this yet. So let me just compile this right now. All right, so let's start by first going into our REPL and creating, this closure. If we go ahead and enter this, you can see that this really is a closure within a closure by simply trying to access using pointer dash star, which is supposed to just func call it, and you'll see that it'll return another closure. Now, obviously, when you do it again, you'll actually end up retrieving the value that it was originally wrapped around in that let block. So that is the value of x. Now, if you let me go back here for a second, and let me just set this to a parameter. Temp pointer. Okay. Now, if you want to actually now set this guy, because we can totally see right now this temp pointer is set to 0. You just need to use, as you can see here on line 18 and line 21, we actually added a generalized variable, so you could do a setf. Does somebody have me on the thing?
Can you speak again? I think it might be gone.
Okay, I just, sorry, I'm hearing myself on the feedback, so I just wanted to make sure that that wasn't me running.
Oh, no, I think, so DJ is just joined, so maybe.
Okay, cool.
So the one comment that we'll have on this platform is that it's bizarre that by default, as soon as you join in, it's already talking with the camera and already talking with the microphone. There's no like pre, you know what I mean?
Yeah, there should be actually a settings that you could set up in Jitsi that allows you to like default to a particular configuration before you log in.
Yeah.
Or
I'll
when you log
in.
Yeah. I just have not had a chance to go through and check some of that stuff out.
Gotcha.
So what's interesting about this example here is so we can actually, since we are able to since we define setfs on both pointer star and pointer ampersand, you can actually go ahead and do something like this, and you can set up and oops, did I do it again? I have a tendency of doing something really dumb. Yes, I did. I did it again. Add an extra. I wrapped it, and then I forgot that when I hit the end of line, it doesn't shoot me to the end of the actual S expression. So when you call setup on pointer star, you will notice that we're actually, like before, like with a normal closure, we're able to manipulate the memory location that the closure actually is in control of. Now, this is because of generalized variables um, and our ability to access indirection environments through closures. We've talked about this when we were talking about Pandoric macros a couple of talks ago. He's using this technique, this Pandoric macros technique of being able to go into a particular closure to manipulate memory location in that closure to actually give you some simulated ability of actually accessing memory addresses and being able to modify them. But for folks who might be thinking, well, this is great, you can actually do C style, like, manipulation here using this technique or this kind of like small little skeleton. Be warned, because these are fixed locations. It's not like in C where you could override and kind of leak into other memory of the environment. It's whatever that environment it kind of encapsulates that you have access to and that you can manipulate. There's other ways of actually being able to deal with this, kind of pointer scoping too as well, and that is dealing with actually assigning and creating a fixed array of some particular size and being able to manipulate that fixed array. But even there, those are just you kind of typed it to like fixed nums. I don't think you can actually get a 100% identical pointer manipulation facility in Common Lisp. But if you're doing like numerical arrays, the next example that I will be showing and that the book kind of brought out, that actually allows you to get some fairly tight, assembly code coming out of it when you're dealing with fixed numerical arrays. I'm going to pause here for a minute just to get some questions on this, because this pointer scoping for me, it took me a while to kind of understand what it was doing, but then I realized, what the technique he was using, the Pandoric macro technique he was using to actually go and simulate this. But if other people have questions on this, I'd love to hear them, or comments. Does anybody? I have a general question for some of the more experienced lispers in the audience. One is this technique ever used? Can we do people actually create like this closure type of indirection environment to like implement algorithms, and does it actually generate efficient code at all, like generate efficient machine code specifically for performance? Has anyone seen it in like production quality code?
I can't say I have. Can you hear me?
Yeah, I can hear you.
Okay.
Elijah?
I suspect that there's an echo on my end somewhere, so I'm being quiet.
Yeah. All right.
Is there an echo, by the
No,
way?
there's no echo.
Okay, good. It wasn't me. I wasn't sure. No, I haven't really seen anything like this.
As far as generating efficient code, I mean, that's really up to the implementation to decide. And, with closures, there's always the overhead of the function itself. So.
Yeah, I would guess the answer to that question is no, personally, generating efficient code. Just because at a minimum, you're going to be dealing with the function call overhead.
Right.
Because it's not going to be able to inline that function very easily unless you're using it, unless you're only calling the function in the same scope, or in the same block of lexical block of code that you created that, in which case, why are you bothering? You already have a reference to that place.
Right. And that's what I figured. It looked like it was just so folks can if folks are coming in from, say, C and C++, and they're like trying to implement some algorithm that they know how to implement using this text, using pointers, this gives them a convenient way of doing it.
I
Actually,
wouldn't say
um,
convenient. I mean, this is a
I
pretty
do
big.
have a place where I've used something similar to that. It's not quite exactly the same thing, but being able to capture a place as a function, being able to capture both the getter and the setter and the setup expansion for a place as a function is actually somewhat convenient at times.
Interesting.
Because places aren't really first class the same way that other objects are. And so there are a couple of cases where I've needed to capture a place, and this is the way that you do that. This is how you
Now,
capture a place.
I was kind of curious. The CL extension with environments that's available, does that kind of like implement this kind of technique? Because it sounds like when you talk about capturing a place,
Mhm.
that's ultimately what you want, right? You want to be able to get some access to the environment that you're,
So, um, mm, so the environment. Which environment extension are you talking about?
the
The
one that's
environment
in that
introspection,
yeah, the introspection environment, the one that's in I think it's in,
CLTL2.
yes, CLTL2, yes.
Yeah. So that just lets you see things like what lexically bound setf expanders are in the current environment. It doesn't let you like do anything with
Oh, okay,
them. It's just introspection.
got it.
It's useful, don't get me wrong. It's very important when you're implementing certain kinds of macros, but it's just introspection. This lets you capture a place at runtime. It lets you create it lets you basically, right? Because when you use setf, right, there's no guarantee that there's I mean, really what it is setf generates code. Setf is a macro, right? And so when you or anytime you use the setf expansion of a place, right, it's just generated the code required for modifying that place on the spot,
Excuse me.
right?
Right,
And really all this is doing is it's capturing that generated code in a lambda. And so you can reuse it. You can swap out the thing you're assigning into the place. Because not you don't always have there's generated code, right? It is only generated code isn't first class at runtime. Probably is the simplest way of describing what I'm trying to say,
okay,
right? The construct that represents generated code at runtime is a function. And
right.
so if you want to capture some generated code so you could reuse it at runtime, you make a function out of it. You wrap it in a lambda.
You just wrap it in Lambda, and then you've essentially have a compiled
You now have
version.
an object
Yeah,
that captures that code,
right.
right?
Okay, yeah,
setf generates some code for you. If you want to be able to capture and reuse that code, the way you do it is with a lambda. That's what lambda is for.
right. Mm-hmm.
Lambda is the object that represents code at runtime,
Okay,
right?
okay,
And
right,
so if you want to capture both the code required to access a place and the code required to store back into that place, you have to use the setf macro, but
right.
then capture the expansion
Mm-hmm.
as something you can reuse. And the thing that you use to capture that expansion, the thing you use to capture code, is a lambda.
Right. Okay, that makes sense.
So that, I mean, that's all that this is doing, really. This is just it's letting setf generate some code for you and then immediately capturing that in a lambda so you can reuse it.
Right, and that's what I mean. This particular, macro here. I mean, that's all it's doing, right? I mean, the one that on line 9 that I'm just kind of like highlighting here. Okay, I'm
Right.
assuming folks can see my screen, right?
Yes.
Okay, cool.
At least I can.
Yeah.
All right. So this really this macro in combination with this setf expander really allows you to do what you're saying, which is capturing compiled code.
Well, I mean, you don't even need the macro and the setf expander, right?
You don't. Okay.
They're just conveniences.
Yeah.
They're very nice conveniences, but they're just convenient shorthands,
Right.
right? You can
This
do all
basically is a pattern. This
Right.
that you could totally just leverage.
Right.
You don't need to necessarily have it. I understand that, but
Yeah.
you see it
Yeah.
everywhere. Refactoring, you want to be able to get it to something that makes kind of sense. So
Right.
you don't see all that code all over the place. But the pattern is valid for a specific case where you want to be able to capture something that was compiled and needs to be used in other places, is what you're saying, right?
Right. Well, I mean, I'm just really, the whole idea of doing, lambda x setf place x, right?
Mm-hmm.
That that makes a function that assigns to that place.
And if I can add my little 2 cents here, so that pattern of basically trying to represent the getter and the setter, which is all that.
Hey, Rom, did you stop streaming your screen?
No, I
No,
didn't.
it's still
I think-
visible.
Okay, must be a bug with Jitsi then. It just went black for me. Let me rejoin.
Okay.
But yeah, so you have the idea of representing a place, by using 2 functions, which is your getter and your setter. That's kind of like the generalized, runtime idea of a place is you need a way to read it and you need a way to write it. What, as opposed to that pattern, in the real world, typically, like in most code, what you're going to see is only half of that pattern. So in most code bases, you'll either pass in a lambda that is going to get called by something else in order to read a value, or you're going to pass in, and it doesn't have to be a lambda, but just a function. So for example, like a map car or whatever else, you'll pass in a function that will get called in order to get a value from it, by some higher order function, or what DJ was saying of you'll have the pattern of lambda x setf something x. Those 2 are very common patterns individually. You don't really see them together a whole lot. Yeah, is I guess what I'm trying to say. So even though this is definitely a useful abstraction, it doesn't.
Yeah, I think I've only
Come
ever
up-
once needed to capture both the getter and the setter of a place.
Exactly. You'll very often want to capture the getter of a place or the setter of a place, but very rarely do you ever want to capture both, or do you need to capture both?
I guess the other thing is that not all places in Common Lisp have functions that you can use as the setter.
Really?
Correct.
Yeah, some of them. I mean, a
well,
lexical variable. So a lexical variable, there's no function that you can call that can set the value of a lexvar.
Right. That's correct. That's
Right.
And I mean, that's a degenerate case, but there are
Right.
other cases where.
Here's another one, right? Is there a function you can call to assign to a spot in an array?
No.
There's not one, no. There actually is one, if you're being really sneaky. It's implementation specific.
So, but here's the thing. You bring up something interesting, though, because the pattern has always been for those kinds of cases is to create a setf expander so that you can access, like in that particular case, and you have a generalized function. So you don't necessarily need it, because what happens is that you're able to, behind the scenes, using the setf expander, generate the same code as if you had a single function that actually accesses the array and sets it, right?
Right. The issue is that sometimes what you really need is a function that assigns to the place.
Okay.
right?
Yeah.
Sometimes you really do just need a function that assigns to that place,
Right.
right?
You don't want all that machinery to go in and do it for you. You'd rather just have it.
Well, let's say you're dealing with an API, right? And it needs to be able to assign to some place, and you need to pass something into this API. And this is a functional API, it's not a macro,
Okay.
right? You can't pass in a place because places aren't first class.
Right. That's right.
You can pass in the result of getting the thing at the place, but you can't pass in the place itself.
Right. So you always need to pass in a function that
Right.
gives you what you need.
Right. You need to pass in some function that performs the setf.
Yes. That's right.
So lambda x setf place x.
That's it. Yeah. You
Yeah.
just need to force. You need to force to doing it.
You need
Yeah.
to do the code generation
Yeah.
in your scope,
Yeah.
and then get a setter function you can pass along.
You can pass along. Right. Mhm.
Right? Because
Yeah.
if you're like if their system is a macro, right? Then it can take the place and it can generate the code that it needs to interact with that place. But if their API is just a function, you need to give it a runtime object.
Right.
And places aren't runtime objects.
Yes. Okay. That makes sense. That makes sense.
Right.
So
And actually also, here's a fun little bit of magic if you're curious. Do you want to know what the SBCL function for assigning into an array is?
I'm certainly curious as to
Call get setf expansion on aref x of some number.
get
Dash setf dash expansion.
set on the
And then
form.
pass in an array dereference place. You have to quote it. It's not a macro, it's a function.
Yeah, that's right. Okay. Aref
X5. It doesn't matter.
X5. Okay.
Oh, SBCL does actually have a setf aref function. Fancy that.
That's what I figured because I'm actually using that.
Not all of them do. Not all of them do. I know that there are at least a handful. Like there's I think row major aref actually doesn't have a setf row major aref function.
So
It has
the reason
actual.
I figured that it had one is because of the next example that I was gonna like. I mean, this is a good segue in here. So one of the things that this book kind of gone through is this notion of creating what he calls a fast stack that will perform as fast as implementing a stack in C, all along with the buffer overflow problems that it comes with C as well, that he keeps on bringing up in the thing.
Make a slight point.
Yes.
So when I said that not all places have a setf function,
Mm-hmm.
that's only kind of true. Because in the end, setf has to expand into something, and the only thing it can really expand to is either a special form or a function call.
Right. Mm-hmm.
Right? What I really meant was not all standard places have a standard function that you can use to assign to them.
Okay, right. You have to define one for that for that.
No, what I mean is that like the implementation probably has one internally, but it's not exposed anywhere.
Oh, okay. I'm thinking of like the user-defined case. What you have to do is.
I mean, like there are actually standard accessors in Common Lisp, standard places in Common Lisp, where there is no requirement that there be a corresponding function that can perform that assignment.
Oh.
Yeah.
Okay. So it's in the standard.
Yeah. The standard doesn't export any setter function for that kind of place. Right? Like
so like aref, if you look at the hyperspec page for aref, you'll see that there's aref, and it'll give you the arguments list for that, and right underneath it, it's setf aref, and it will give you the arguments for that. So it is telling you, hey, aref is a setfable place. Now, it doesn't tell you that there's a setf function, or that there's an
Actually,
expander.
if it specifically says setup aref is a thing, then that does require there be a setup function, I think, doesn't it?
Oh, does it?
Yeah.
I'm
I would
fairly
think
certain.
so.
Yes, it does.
But
Yes, it does.
but I think row major aref is one that is called an accessor but doesn't actually have a function defined.
Oh, I see. I see.
No, actually,
That
that
makes-
has F2, just like aref in the signature.
Hold on. You said row major aref.
Oh yeah, no, I'm wrong. 1 second. There are a few I've run into. I know that there are a few I've run into. Let me think.
This one doesn't in SBCL. Row
Oh, yeah,
major
there we are.
aref
Yeah.
gives
Okay, so that's
you
interesting.
an internal function. Yeah.
But
But
yeah,
does the standard say that it should have a setfable function? I mean, I didn't think so.
I guess I didn't interpret that correctly.
Yeah, I've always understood it as if it's
Oh,
you
right,
can call
yeah.
setf
It's
on
just
it.
saying that you can.
Exactly.
Right,
It's saying, hey, you can call setf on it, but it doesn't tell you if that's implemented through a setf function or if it's implemented through an expander.
Yeah, all it says is row major aref is valid for use with setf. That's all it says.
Right. And so if you're being portable, there's no function that performs the effect of setf row major aref.
Right.
Yeah, exactly. If you're being portable.
If you're
Right.
being portable, there's no guarantee.
Well, there's right. If you're being portable, there is no portable function that
Yeah.
performs the effect of setf of row major aref.
Right. It's just
And
the only requirement the standard says is that it should be set.
that there is some rule in setf for how to handle that place. But
Right.
it doesn't tell you what kind of rule it is. It doesn't tell you if it's a setf function or if it expands to some internal function or
That's
if it's
the only
something else
requirement.
entirely.
Right. Okay. That makes sense. Okay.
Right. And so there's not.
It's a
It's
bit of
not
a pain, but that makes sense.
And so I guess my point is it's not always possible to do something like, with con cells, for example, right? The corresponding setter for car is our placa, RPLACA, I think. Replace car.
Replace car?
Yeah.
Yeah.
Okay. What about replace car?
RPLACA, right? So that is a function that performs the effect of setf of car.
Yes, I think. Yeah, that's right.
Right? And so what you could do is you could say, if you wanted to pass in a setter function into some library that expects like a 2-argument setter function, for example, you could pass in our placa directly. Right?
Yes.
But you can't do that with row major aref.
Oh, yeah, that's right. That makes sense because there's no guarantee, like you said. I
Right.
mean,
There's no function for it. There's no portable function for it.
yeah,
So you'd have to make one by doing lambda AI row major setf row major aref AI
so
value.
you literally
lambda
have to write this out and say
AIV probably.
it's a row major. Well, yeah, that's right. A
AIV because you need a value.
index and B, right?
I was saying V.
Oh,
Value.
V. Yeah.
It doesn't matter. Alpha renaming, but
A I guess. Yeah.
Yep. V. Right?
Yeah.
And so you can definitely do that, right? And that gets you, a function that does the job.
And now you can take this function, pass it to whatever, and you'll be
Right.
that needs a setfable function, and it'll be fine.
Right. Oh, well, I mean, it wouldn't use setf. It would call it like any other function. But the point is that that's an object you can pass
Yeah.
around.
It's an object that, like, internally, when this object gets compiled, it will replace that setup row major aref with that call
Yes,
there, right?
kernel.
Yeah.
Yeah.
Okay. Got it.
Yep. When the setf expands to compile that function, it'll fill in the call to SB kernel set row major aref.
Okay. All right. Okay. That makes sense.
Yep. Lambda the ultimate.
Very, very nice. Very interesting. That's there's a lot of these little tidbits about the standard.
Yep. places aren't first class. It's one of those little things that you don't realize is irritating until you run headfirst into it. It's nice for a lot of reasons, performance among them, but it's one of those things that gets irritating when you run headfirst into one of the cases where it'd be really nice to capture a place.
I mean, it's not only performance, right? I mean, like performance is nice for me, at least, but the other thing is there's sometimes having places as first class gives you some control over, isolating a particular like set of changes, right?
No, I mean that having places be macros that get expanded away is good for performance.
Right. Oh, right. Okay. Right.
There's not necessarily like if you can inline a call to a particular internal accessor, right?
Mm-hmm.
Then you instead of having like Python, for example, has properties. A lot of languages have properties, right? Things that look like fields but are actually handled by a getter and a setter function, right?
Mm-hmm.
That setter will never be inlined, ever. Can't be, right? Because it's a regular function call.
That's
I mean, you might have a JIT compiler that's doing sneaky clever nonsense, but in the absence of some, JIT compilation sneaky clever nonsense, it's never going to inline that accessor, the setter, right?
right.
But
Mm-hmm.
because places get completely compiled away in Common Lisp, you can compile down to some low-level primitive function that the compiler knows how to inline properly.
Right.
In certain cases. And that's why setup of aref can be really nice and efficient without you having to know whatever internal function nonsense has to happen for that to work. And I'm being a little unfair to properties here when I say that, but my point is that
You've been burned by
forcing,
properties in the past. That's probably why you're being unfair to properties.
yeah, a little, yes. My point is more that defining setup this way leaves open the door for a lot of places to be compiled away entirely,
Yes.
right?
Sure.
Without needing magic that's actually inside the compiler to do it.
But you could certainly here's my point, right? You could certainly see like in this case right here being with a good sufficient compiler being able to compile away if there's enough hints.
Well, setup aref does get compiled away on this BCL.
Right. I'm just saying that
function call.
I'm saying that there should be at least I don't see any reason why you can't use whatever techniques that you use to compile away setup aref to have a setupable row major aref in the implementation and have the same techniques to be able to compile it away as well.
There's nothing stopping that.
Yeah.
Really, I'm more talking about the additional overhead of if places were forced to have a runtime representation.
Oh, okay. So you're like talking about things that have multiple purposes, like say C Lisp, like if you're trying to embed it in an application, like a Lisp interpreter inside, right? So you need.
Well, like I'm trying to justify why it's valuable for setup to be entirely a macro and for places to not be first class.
Got it. Okay.
Right, and the reason is just that there would be a non-trivial overhead if you forced places to be first class at runtime all of the time. And there's not a whole lot of value of forcing compilers to be clever enough to compile away the places again, when you could just make it a macro and have it, expanded away automatically. And when you really do need it, you can just wrap the places in lambdas. And so, like, I'm kind of irritated by it because it made a project that I was working on a while back a lot more irritating to solve, and I still haven't finished it yet, so not going to go into more detail about that. But as a general rule, I like the way that places are implemented. They're a quite nice little abstraction.
Elijah, is that more because it's not thought out from like a performance perspective as much as it is from, I guess, like the historical development of the language itself, where you weren't necessarily like manipulating things down at that level, or is this? Do you think this was more like a thought out thing for just strictly performance reasons?
Actually, honestly, I don't think that either of those was really the reason setf was created. I think setf was created because people got tired of having to remember what the setter function was for each of their getters.
No, I mean the fact that the places aren't first class.
Oh no, I think that that's literally just because it's easy to do it that way, easier than you'd think anyway. Just to implement it as a macro, and I mean, I suppose it would clean up some bits of getSetF expansion if places were always implemented as setter functions, because you wouldn't have to have all the machinery of getSetF expansion. But
by doing that, would places become first-class citizens then in the language?
if you required that every single place had a corresponding setter function,
Yeah.
yeah,
Okay. Got it.
yeah. If there were a guarantee that for any place you could setf, you could also do fun call of setf function name, places would effectively be first-class objects in the language. Not quite. It'd still be, you'd still need to curry a function, you know. Really, what it would require for places to be first class is if there were an operation not unlike, I mean, basically the macro that you've written here, you know, the pointer ampersand, right?
Yeah.
If that were basically baked into how the language worked, right? And if setf were basically implemented in terms of, instead of this being implemented in terms of setf, if it were sort of the other way around, if for any place expression you could, you know, do some primitive operation on it that would turn that into an object or a function, I guess, that you could call to assign to that place, right? And then setf were just a bit of syntactic sugar for get the setter function for this place, and then call that function with this value, right? Because then you could basically at any point just basically pass these place objects around.
Right.
If the primitive operation were take this place expression and make a place object out of it for me, and then setf were just the combination of do that and then immediately use it for something, right? Then you could pass place objects around.
Right, and then the compiler will have enough information to be able to recognize what it needs to do.
Yeah, but no, it wouldn't though. I mean, maybe it would, but it would be the compiler would have to be inlining the setter functions instead of setf inlining the setter functions.
Okay.
Right, because the way that it's set up right now, getSetF expansion is used by setf to inline the call to that setter function without the compiler getting involved. Right, that happens during macro expansion. No need to bother the compiler with it. Right, whereas if places were this kind of first class object sort of thing, then the compiler would have to be able to basically detect that you're creating a place object just to use it once and then get rid of it, and then, you know, do that, and then basically just optimize away the allocation of the place object and inline the code that would otherwise handle that assignment, right? And that's actually a much trickier optimization. I mean, there's no reason why you couldn't design a compiler to do it, but it's better in this case to avoid burdening your compiler with code that creates objects only to not use them.
Yeah, the very idea of generating unused objects or garbage stuff.
I mean, it would get used. It just only gets used once.
No, it's a temporary object. It's a transient object. Right. I understand what you're saying. It's just if it's only limited for the same purpose, there are much better ways of doing it than doing a construction, only use it once, throw it away. It's marked for garbage collection. If you have a lot of these over time, then you'd
have to basically rely on your compiler to realize that it doesn't actually have to allocate them.
Right. And that requires just, I think
it's not too tricky to do. It's just it's not trivial. It requires it puts more burden on the compiler for something that could fairly easily be handled entirely at macro expansion time.
All right. Cool.
Anyway. Detours.
So, I mean, you brought up an interesting point, though. Like, one thing that a lot of this book says, and Michael kind of alluded to it, earlier on when we started talking about this, is the techniques that are brought up in this book, right? You need to take it with a grain of salt. As I've been reading this book, I've been trying to think of ways of and examples of where this is being used in the real world. Can you use this in real production code, or is it just kind of a trick? Are there better ways of doing it than what the book is kind of suggesting? But it brings up some of these topics on efficiency that sometimes when we're writing Lisp code, we wouldn't, until it like bites us in the ass, we don't actually like kind of think about it. So just topics to bring up that I thought were pretty useful. He goes on in this particular section to kind of like talk through, and we've kind of done this last week, but just a quick review of using type information to bring assembly down to basically the equivalent of C code. So I have a couple examples here that I'm not going to really go through, but just quickly just show you for folks who may not have seen this from last week, how just adding simple type information and then eventually turning on optimization will change code from a lot of instructions to giving enough information to the compiler to really pack it down to as few instructions as possible. So this original implementation of this Lambda function that I created, this is one thing I want to bring up. Like in SBCL, according to the book, it should kind of do the same thing as Carnegie Mellon, and it should pass into some, check bounds, and then it was some sort of like function call that it uses to go and access the actual array reference, but I don't see that in here. I don't know why. He particularly calls it out in his example. It was, what was it again? It was called data vector reference. Like, I didn't see that being used in here, but I assumed that SBCL does something similar to access the reference of the array, right? Like in the machine code. Like,
I mean, what's the jump at the end they're doing?
Hairy data vector.
It's just checking the bounds of the.
Nope,
vector.
that's not that. Hairy data vector ref / check bounds is the dereferencing function.
Oh.
It's just the version of it that also checks the bounds.
Okay. All right. So I thought this was just, doing a bounds check. I was like, okay, where is it actually accessing the reference? Okay, so that I wasn't sure where it was being called there. I did notice though that as soon as we added type information here, it shrinks down by like one instruction, really literally, and gets rid of the bounds check. But it really isn't until we turn off everything and say, hey, just go and be a speed demon, would it shrink down from 47 bytes to 11 bytes to actually do, for most folks, this is kind of straightforward. It actually just goes in, figures out the offset and then computes what it needs to do and then returns from. So right here in B6, it's just accessing the array plus its offset to actually get the contents that it will then store in the destination register before it goes and returns from the function.
Wouldn't you want to declare the size of the array in that type simple array fixed num? Because you're turning off safety and therefore bounds checking.
I mean, depends on the code you're working on.
Yeah, true.
Yeah, you could turn you if you know the size of the array, you could also add it in here, and that could do some additional. But I didn't. If you don't know it, then the only thing you can do is say it's just a simple array of fixed nums, optimized for speed. But this actually still has a buffer overflow, if I'm not mistaken. It's just it's not shown here.
What do you mean by a buffer overflow?
You can actually the way this is written and the way it's generating the code, you can actually access invalid memory, right? In this case,
Sure.
because the check is gone, so it's not going to throw an exception at all.
You could pass in like anything. It doesn't even have to be an array there, and it would try to access that memory as if it were.
Yeah, it's a pretty.
Which is not a good idea, just so we're clear.
We're not encouraging on this stream for you to go and access whatever the hell you want by doing this kind of technique. That's not what we're advocating here. I'm just illustrating for simple, purposes. The last thing, like this is one a particularly involved macro that I wanted to kind of discuss. In here, so his background about using this was that let me just explicitly quote from the book rather than me actually pretending I know exactly what he said. He right here. Here we go. So the reason he wrote this example is that it efficiently accesses arrays, and it specifically becomes extremely efficient over time. So he's talking about the amortized time of what's being generated by this code. So I wanted to discuss that. So I wanted to first, go through an expansion of this so that you guys can see what this does. But first, let me just delete this guy because this is actually not in the original code. That's me fixing something. So let's compile this and let's look at its macro expansion. So what he was trying to do is try to show that, if we disassemble a Lambda function that leverages this macro, it ends up generating a fairly tightly wound loop for inputting values into the stack that he created it. And when you go in and expand this guy, what it does is it generates three functions based on the stack that your name that you pass in. So right now we have something called input. So we went ahead and created three macro functions. One called fast push input, another one called fast pop input, and then obviously to check the stack size. Although, just to give you a heads up, even in the book, he doesn't actually leverage check stack input, which he should, because later on when he tried to run this guy in code, it actually throws an exception because it goes down a couple levels deep, and then it basically makes Lisp complain, saying that, oh, I can't recurse out of this, and it locks up. So I'm just going to
raises a condition.
Yes, sorry. Yeah.
I didn't want to be the one to say it.
Yeah, it's a condition. Yes. That's right. It raises a condition. I'm sorry.
Can you disassemble that?
Yeah, sure. So this is what it generates.
You could probably generate a little faster code, actually. I'm just noticing. Just get rid of the for I from 1 and change it to repeat.
Yeah.
For I from 1, 2.
Repeat.
No. Get back what you had. Delete from 4 to 2. And change it to repeat.
And
For I from 1, 2. Get rid of that.
I did.
I don't see it.
Can other people see it?
Yeah, I can see it.
Yeah, I can see
Your
it.
stream is frozen, Michael.
I would.
So I was having a lot of trouble with that. Like earlier, it just crapped out on me completely, and I reopened it in like with all my extensions on my browser disabled, and that seemed to help. Oh, he's gone.
Yep, he's restarting.
Okay.
He's restarting his.
I was trying to say, Michael.
Yeah. Okay, I see it now.
Yeah. So,
Second time that happened already. Wow.
I was having a lot of troubles earlier. Like it was just freezing on me left to right, and I actually came back on with like all my browser extensions disabled, and that seemed to get everything fixed up. So that might be a thing that you want to try next time.
So this actually shrunk it by a few instructions, although it's still roughly equivalent, from what I can tell.
Yeah,
Here.
you just get rid of that, that binding that you're not using, the I.
Yeah. And let's see, yeah, it really is pretty small. But it does exactly the same thing. The one thing that I tried to do is I wanted to see, well, how fast is this really? So I basically tried to time it. I wrap this guy, and then I tried calling it with some value. So it's trying to push 5 into this array a million times. All right, and at some point, it gives me this error. Shift. 11 nested errors, maximum error.
Yeah, don't do that.
Well, I locked it up now, so I'm gonna have to restart my Lisp. But I was like, "What is this?" I was like, "I never seen this error." So,
well, I mean, what do you think SBCL does when an error happens while it's trying to print an error?
Yeah.
It
Okay.
enters a recursive debugger session. When it gets 11 of those down, it gets really mad at you.
Got it.
Because I mean, like the debugger is still, it's still regular Lisp. It's still at the main level. So, it's running regular functions, and it can have errors happen while it's running.
Right. So it's hitting multiple. So I figured that was the case. So it is causing causing multiple.
When you hit 11 nested errors deep, that generally means you've corrupted something involving entering the debugger.
Yeah.
And so it tries to enter the debugger, gets a condition that triggers the debugger, which gets a condition that triggers the
debugger, and so forth. Right.
Yeah.
Hold on. Pull up. All right. So, point is this is a straight up port. Didn't work. I'm trying to figure out what exactly is kind of missing in here that would prevent that from happening. So, if you guys tend to do the same thing, I'm pretty sure you'll come to the same kind of situation, and you'll be wondering what the hell. I don't know.
That code doesn't make any sense to me.
Yeah.
Actually, now that I'm looking at it a little more closely.
What doesn't make any sense to you?
You can't push that many times. You're gonna write off the edge of the end of your array.
Right. Well, that's what he tried to do. I was like,
that repeat is way too high for the size of the input.
Yeah.
For the size of the array.
I think, but if you look at what he do not.
I can't see that stuff that's in the chapter that's not free.
No. I'm just showing the.
What? You don't have the book?
Nope.
Buy the book, man. I'll send it to you by email. Via mail. It doesn't have an ebook version.
Maybe
I'll
someday.
Oh yeah, you're probably right. He'd that must be a typo.
Yeah, if I do this
Yeah,
should.
that's fine.
Yeah. Yeah, I think that's a typo.
Oops. 1 second. Now. Okay. Shift. Okay. Now compile and compile.
Well, that's just gonna.
Yeah. Well, this is the compilation time. I'm an idiot.
Yeah.
I should have.
No, you're not. You're not an idiot. It's just,
Yeah. All right. This should now. Good. Wow. It's that's pretty fast.
I mean, like, benchmarks are useless in a vacuum.
Everything is used. Yeah, micro benchmarks are probably the worst illustration, but it's better than nothing, is what I could say. But it's funny you mention benchmarking, because writing benchmarks is something that you might want to do, at least according to Hoyt. I don't know what he's thinking, but that's fine. To benchmark your compiler to see whether or not, for your particular Lisp application, the implementation actually does what you expect it to do. And he gives some ideas and macros and functions that I really don't want to go through in detail, just because I have my own opinions on whether or not this is actually useful or not. In general, benchmark profiling your tools that we talked about last week is probably more useful to figure out in your specific case whether or not there might be certain bottlenecks that you could leverage for your Lisp implementation. And if you wrote it in portable enough common Lisp, you can almost guaranteed take the same kind of profiling code and move it to another one that has a profile, another profiler, and you probably might see the same bottlenecks. So you should be able to then use that as a way to go and improve your code. Writing benchmarks in general don't necessarily give you the information that you need to see where your slowdown is. So that's just my thoughts on it. And this is regardless of system. Collecting data and being able to analyze your bottlenecks are probably more useful than benchmarking. Yeah. So today is kind of short. This is all I had, but I'm opening the floor for other topics for discussion. Tim, since you are since you were kind of new and you were bringing up earlier of that this is kind of your foray back into reading Let Over Lambda. Did you get a chance to see some of our earlier discussions on profiling Lisp, and even some of our discussions on macros? And do you have any questions?
No, I hadn't taken a look at those. I certainly will go back and see what's there. Do you have a link to your YouTube?
Yeah, it's all of our videos are on the AFP YouTube channel, but I can certainly post it again on this on Jitsi if you just give me a minute, and then any other topics of discussion from the folks. I wanted to know what people's thoughts were about LTK, actually, because I've been playing around with LTK again recently for quick GUI prototyping, just because I'll be honest, I can't for the life of me. Well, after switching to Qt5, going back to Qt4 is not one of my favorite things to do. So I started writing.
LTK is better?
LTK is for quick prototyping, buddy.
That's fair. That's fair.
Yeah, that's been my experience as well. I was actually very surprised to see LTK just sort of just works.
It just works.
It doesn't look pretty. It's but
well,
I used it for one homework assignment.
It depends.
It just works.
It depends. Here's the thing. On Mac, it uses the native Cocoa widget set. So on Mac, it looks good enough. So when you're working on Mac, it doesn't it's good enough. Let me just put it that way. It's good enough than using like say Qt4 with the CL. I'm forgetting what the binding is now for Common Lisp for Qt4. If folks know about a Qt5 binding Common Qt, that's right, Common Qt, that's right. If folks know about a Qt5 binding or an experiment, even an experimental
the only
one,
person that would be capable of pulling something like that off would be Shinmara, and he seems perfectly happy sticking with Qt4 for now.
I've actually looked at Smoke the other day just to see if there's a way for me to take a stab at it, and I'm just like, man, KDE did a lot of stuff, but they did not make writing bindings for Qt very easily still. So
see, what I would personally really like is for it to be easy to get G-object introspection, at least a version of GTK with G-object introspection, functioning, compiled on Windows without it being an absolute headache.
Actually, you bring up GTK. That's another one I did successfully use like very long time ago. I do remember it being slower than dirt. For whatever reason, on boot up, it was just it literally took like 10 seconds for the window to pop up. I don't know if it was just something weird with my process or what I was.
I don't remember having that kind of weirdness.
So there is a library called EQL5. It's written specifically for ECL, Embedded Common Lisp, but it's got Qt5 bindings.
Yeah, and that's the one that's used for the Android application, isn't it? The CL repo.
Yeah.
So I suppose if you're being, ECL specific, that gets the job done.
Yeah, for sure.
Doesn't look terribly well. Well, there's a doc folder. Let's see. Yeah. So they have some stuff in there. I may have to take a look at that eventually.
G-object with introspection. So do you want a common? Isn't there a Common Lisp binding for?
Yep,
is there
CLG object introspection. It does its job properly. I've used it on multiple occasions. I actually quite like CLG object introspection as systems like that go. It's just, I only know how to do it on Linux, where I already have GTK nice and compiled by my package manager. And I don't really want to learn what the nonsense I have to go through to get that to work cross-platform is.
Yeah, there's also a way to, if you by using LLVM, you can actually generate the C files from C++ library for your CFF5 bindings.
Yeah, you can do that with LVM. There's also Swig does stuff for that.
I think LLVM does a better job than Swig.
I wouldn't be surprised, but Swig actually can also generate CL side stubs as well. So
I've used Swig, and Swig, I'll be honest with you, like it can get you to a certain point, but
yeah, it's a bit. Yeah, it needs help.
Yeah, the LLVM way will get you through any.
Right.
Yeah, LLVM definitely is going to be better.
My only issue.
So,
go ahead. Go ahead.
I was going to say, like, literally the author of Swig hates it because it was meant to be just like, hey, I'm trying to make bindings for this very specific library, from Python. That was his use case, and then just sort of like went out of control. Yep. LLVM is more realistic just because it's an actual compiler.
True.
An actual C++ compiler. So it with Swig, it still has certain parsing bugs.
Yep.
So what you could do with LLVM, it's nice, is you can, especially if you end up using, I hate to say it, the OCaml bindings, you could quickly write your parser in OCaml, convert it to LLVM IR, and then use the LLVM framework to then generate.
So
Once you
Have you seen CL auto wrap?
know,
Because that's basically exactly what it does. It calls out to an application called C2FFI, which uses LLVM to do all that, and it spits out a big fat JSON file for different architectures and with all the symbols, and then it consumes the common Lisp library will consume that to generate the bindings automatically.
ooh,
Memory served
My
compiling it
feelings-
is a headache, though. C2FFI, that is.
Yeah. So the good thing with C2F with CL auto wrap is the fact that once you have those spec files, you don't have to like rerun you don't need LLVM anymore at that point, unless you're going to like regenerate them. So once you've done the extraction process, it'll create these spec files that you can basically, use 100% CL on. And that's the benefit. But it is still automatically generating, approach. And every single time that I've used any sort of tool to automatically generate bindings, there's been some corner case that takes me literally longer to solve than if I just wrote the bindings by hand.
Yeah.
So
that's actually the reason why I haven't done any more work on my bindings for RenderDoc. Because RenderDoc's API is blisteringly irritating to work with, because it does this really funny thing, right? And I kind of get why they do this. It just drives me up the wall. There is no actual top level RenderDoc API. There's a type def for a struct that contains a bunch of function pointers to all the functions in the API, and then there's a single actual top level function for requesting a pointer to an already allocated and populated struct.
Right.
That has all those pointers, right?
Basically like an extension.
And C2FFI has no idea what to do with that. C2FFI takes one look at the function pointer members of that struct and just takes a step back and takes a few deep breaths. It does so it does generate accessor functions for the struct, right? But those just get me the pointer, right? And
you want to actually call it.
And CL doesn't have the type information for those struct members. So to actually make use of the struct, I basically have to manually write a little wrapper that calls CFFI foreign fun call and annotates each of the types of the arguments by hand.
So it doesn't actually get you completely the way there, but it gets you close enough where you could leverage CFFI to actually.
I mean, I could do this all with CFFI by hand regardless,
True,
right?
but if you get, if you could get like 70, I mean, if it's a fairly large library.
Oh no, it gets me. It doesn't get me anywhere at all. All it gets me is functions that that access the struct, right? But all that gets me is a bunch of void pointers, right?
Right.
And so I have a wrapper for the top level function for getting a pointer to the struct, and that's nice, right? And I have a bunch of accessor functions for getting the pointers in the struct, and that's nice. But that's basically nothing compared to what's actually required to interact with the library, right? Because
now you've still got to create wrappers for each and every one of those function pointers.
One by one. Yeah. Because I don't have the type information for the void pointers that those accessor functions are getting me. So I can't just call them. I have to do a foreign fun call, and when I do that foreign fun call, I have to annotate each argument with the type of the argument and annotate what the return type will be.
Wow.
So basically you're saying that if it gets you like 75% of the way there or 60% of the way there, no, this gets him literally about 5% of the way there. it's able to create the struct.
Basically, all it's done for me is translated the struct definition over to CL.
Yeah, which doesn't really help at all. It doesn't matter.
And not even that. It's translated the struct definition as a bunch of name is of type pointer. definitions. That's all I've got. And so I've wrapped like 3 functions in the API. They're the useful functions, in my opinion, for the very basic interactions with that system. But it's basically nothing compared to what's actually accessible through the API, because I just don't want to spend the time to wrap every single function in that API by hand.
So, sort of switching gears, but
Sure.
the other one, so you got CL auto wrap, and then Borodust created Claw recently, which is a fork off of CL auto wrap to try and address certain things. So that's another one worth taking a look at. And if I basically sworn off.
Does it depend on C2FFI still?
Yep.
Yes.
I just
Now-
noticed that one of the big problems I had with auto wrap was C2FFI. The author of that library, C2FFI, and the original auto wrap, left Lisp about 3 years ago, and he sort of just left C2FFI hanging. And C2FFI depended on a very old LLVM, so trying to get the required LLVM version installed on a system, a Linux system with new libraries, was more than a pain, to say the least.
I've done it on Windows a couple times.
He just recently updated it, though. So he just recently updated it finally about 2 months ago. It now supports the latest LLVM, which is great, in my opinion.
But what
That makes
sense. And so what I was going to say with that is like even though I've sworn off CL auto wrap for the foreseeable future, just because I've had so many headaches with it, like I don't want to deter anyone else from using it, especially if they think it's useful. For me, I've had too many headaches with it. But if I were to go back into it, Claw is what I would use, just because Borodust is still maintaining it, so it's a more active maintainer, and some of the changes seem promising as well.
Yeah. And my trouble is anytime is like, I don't know, it still doesn't really solve a lot of stuff. I don't know.
Yeah, exactly. That's how I feel about it. Is if I just write these out by hand, like I don't have to debug arcane little like weird issues deep in the generator, and like it's just CFFI code, right? So like I can come back tomorrow or next week or next year on a different computer and like just load it, Whereas like getting C2FFI built again was, oh my god. Or anytime that I had to do like groveling through CFFI, again, I'm on a Windows machine, all right? So you can complain all you want about trying to set up LLVM, like the right version. Like I've been through that to the end level. So.
Yep.
So, I mean, I'm kind of curious about this because you're bringing up LLVM a couple of times here. Does CL have a decent LLVM binding one can use? Like, I
It
just
does
hear
have
no.
one created by this guy that left Lisp even longer ago, like 10 years ago. But I'm sure that's not really usable at this state.
So that's the reason C2FFI is a separate application.
Yep.
Is because otherwise there wouldn't be that much of a headache if you could just call LLVM from your CL for CL auto wrap, but that's not how it's implemented.
Also kind of the reason why clasp is a thing.
Exactly.
Which I heard they're trying to get rid of LLVM and use a native compiler.
Only kind of.
Okay.
Yeah, they still want the interop, especially with like the runtime and everything.
Yeah, no, they are replacing the compiler they're using for main Lisp code gen with one that's better optimized for interactive Lisp code gen. But they're still relying very heavily on LLVM as part of the runtime and the framework for interacting with C and C++ code.
Oh, I was going to say, that would have been
a
test at this stage in the game.
Right, yeah. No, really all they're doing is they're replacing how they do code gen for the just purely internal Lisp stuff.
Well, I'm curious, though, that if they did go in that direction and write native Lisp code gen, because isn't Clasp using essentially that one thing from Sickle?
It uses Sickle to come up with the LVMIR, if I remember correctly.
Right. So I'm just wondering. Well, that's basically them switching over to they're removing the sickle dependency, which
No.
right.
I mean, if anything, they'd be reinforcing it.
Yeah.
If they went that way.
They're using sickle. Sickle isn't for generating LLVMIR. Sickle generates its own high-level intermediate representation, and then Clasp translates that to LLVMIR.
Okay.
Sickle is just nice because it's a compilation framework for going from regular Lisp code to an IR.
So they recently did a talk in the was it the 2018 LLVM conference?
That sounds right. Yeah.
I'll try and pull up the video, but I highly recommend that everyone that's even mildly interested check out that talk. Just because it gives you a good state of where they're at and how that whole process is laid out for how they do their compilation, their runtime interop with the debugger and all that.
That was the talk that I was kind of referencing. You're talking about the lessons learned talk from Dr. Meister, right? The one from last year.
Yep.
Where he goes through instead. Yeah. Okay. Yeah. Because I heard that they were switching. I remember in that talk he mentioning something along the lines of them replacing something, and then I started thinking about it. I was like, well, wait a second. They haven't actually implemented this piece yet in Clasp. It's dependent on sickle. So what are they doing with sickle? So I may have misread or misunderstood.
Yeah, no, they're keeping sickle. What they're doing is they're replacing the actual code gen backend from one that generates LLVMIR and then uses LLVM to one that just directly generates assembly.
Got it. Okay.
But it's still interoperating with the LLVM runtime. So one of their huge things that they were advertising there was, for example, like you're able to hook up the LLVM like debugger onto that and like see stack frames with like common Lisp functions and step through them.
Common Lisp and C++ stack frames.
And really cool
stuff.
stuff.
Yeah.
That's
so
really
they definitely
cool
don't want to lose that.
Yeah.
Well, it always kind of bothered me that that Julia ended up doing the same approach effectively, and I was like, well, why don't you guys? I mean, you guys seem to be the same community trying to attack the same problem from different angles. Although in Julia's case, they've ended up essentially inventing a brand new language to actually tackle numerical computing. Would it be just easier just to reinforce Clasp and say, hey,
So Julia's entire framework is actually very different from Common Lisp in a lot of ways. Like Julia is, like in some sense, you're right. Like it would have been nice to reinforce Clasp, but Julia is actually really kind of doing its own thing. Like Julia's semantics for functions, right, is what's interesting to say the least, because Julia lazily compiles methods with the actual similarly to how Common Lisp's generic functions, right? They get lazily compiled with the specific invocations for particular types, right?
Right.
But Julia doesn't do method combination. Julia doesn't do any of the other dozens of things, and it is actually statically typed, which means that mostly statically typed.
Well, you don't need a method combination unless you're implementing like multi-method dispatch or even like implementing like clause, right? Like in Julia.
Well, so Julia doesn't have inheritance, not for types that have actual fields.
Right.
You only have inheritance for abstract types in Julia, or you have subtyping for abstract types, I guess would be the better way of putting it. Right, and what that means is there's always exactly one method that will match for any given type. In Julia, the way that they have it all set up, and their system is just that they actually, with any combination of concrete types that you call a function with, right, it actually recompiles the body of that function specialized for that specific concrete type. and then it records that compilation, and then it puts in and then it probably inlines the code body for that into whatever tried to call it.
That sounds an awful like how C++ templates work for functions.
Yeah, but C++ templates happen at compile time.
Right.
Julia does this lazily.
Well, it's compile time in that, after the first pass of grabbing the functions, anytime it finds a template,
Right.
it'll instantiate that template, right?
So the whole thing about Julia is that it's basically it's interactively and incrementally compiled.
Right.
Right. And so you keep the kind of nice high level interactivity that you get from like Common Lisp to some degree, but you get the inline high performance from something like C++.
Right.
Right.
Okay.
And that's really what Julia is going for. And the side effect of this is that actually, and there was a great little demo at ELS a while back that they did, is that their entire math stack is written entirely in pure Julia and relies just on a couple of primitives for working on bit fields, right? And so all of their rules for like type upgrading, for like, when you multiply an integer and a float, all of their generic math operations, all of everything is implemented in pure Julia. But because their system lazily compiles methods specialized on the actual concrete types, there's actually no runtime overhead for that after the first invocation. And so if you disassemble a call to one of Julia's generic math operations, you get the inlined assembly for that specific operation specialized to the specific concrete type you tried to use it on. It aggressively inlines all of the things, in short. And so Julia's compiler basically, like, it's doing some very different things than Common Lisp is. It's not. It's interactive, but it's not really designed for heavy redefinition of stuff because it inlines stuff everywhere.
Right.
And that lets you interactively develop a high performance application to some extent, but it also comes with other bits of weirdness. So Julia is doing something fairly different from what Clasp is doing in that sense, right? Clasp is trying to be an interactive environment for doing high performance physics simulations. Julia doesn't quite support that, quite the same level of interactivity as you can pull off with something like Clasp, because it inlines too much, basically. And the lazy compilation is much more it's specific to very concrete types, right? Their type system is much more focused than Common Lisp's type system is, so that you don't have to deal with all kinds of crazy inheritance nonsense. And so you always know exactly which method will handle a given type when you're looking at it, and stuff like that, right? Julia's whole system is designed to make it fairly easy to lazily at runtime inline a very high performance implementation of a given function for the specific types you called it with. And Common Lisp isn't quite designed for that. They're very different kind of approaches to language design.
True, but I think, and I guess my point is I feel that there's probably a way for Common Lisp to do kind of the same approach that Julia is
Common Lisp
doing.
would need a lot more static type information for that to be feasible, and it would take away from the interactivity.
So what are your thoughts on NumCL then, its approach to actually...
I haven't looked terribly closely at it, but I imagine it's probably doing the same thing that NumPy does in Python.
Okay.
Which is it's dynamically typed at the high level, but it's very high performance statically typed in the internals, and you're relying on the fact that as you operate over larger and larger data structures, you're not or data sets, you're not making near the detours back into dynamic type world become much smaller fractions of your overhead.
Right. Because I mean, they're still working on it. I mean, it's going to be a while before they would be, at the almost feature parity, although I don't know if that's their intent over time to have an exact feature for feature match with what NumPy has. But I was curious where other folks' talks on it. So
right. Well, I mean, so like, I mean, NumPy works, right? Because as you're dealing with larger and larger high performance data sets, it makes more and more sense to do a couple of dynamic type checks, right? At the head, right, and then run some very optimized internal routine over your entire really massive data set, which itself doesn't do the dynamic type checking. It's entirely static, right? And with NumPy, that's done by dropping down to C for the accelerated routines, right?
Certainly.
And so, and you can do that in CL. You just have to annotate types everywhere when you're doing the internals.
Right.
And you have to annotate types like everywhere. And it gets really verbose.
But
not really much more verbose than C.
What? Say that again?
Not really much more verbose than C.
No.
Right.
Michael, you made a comment. What was that?
Yeah.
I was just talking about specialization store.
Yes. Yeah. No, don't worry about that one. Better to do the dynamic dispatch at the front end, and dispatch.
Which, for those who don't know, it's a way to create generic functions in a sense of the word for types rather than classes. But like Jace said, it requires the user to annotate everything with types.
Yeah, basically, it uses a compiler macro to inline a specialized version of your generic operation based on the declared types of the arguments. Which means that if you want it to actually do that inlining properly, you have to declare the types of your arguments everywhere.
That may not be a bad thing if that's what you need.
Yeah, just it's definitely an option. It just ends up being really verbose for most high level user kind of code.
Yeah, probably useful for internal code, where that API isn't exposed to users because users do not want to be doing that.
We were talking earlier about profiling, and that's what it comes down to: is it going to be useful in a non-bottleneck scenario?
Right.
So.
And that's a very important point, though, right? I mean, why I think profiling is far better than benchmarking to get statistical, because you need that data collection to figure out what your bottlenecks are, and then you can leverage techniques like adding types at the appropriate places, adding the optimization flags in the appropriate places to actually.
Well, I mean, if what you're writing is a high performance math library, it never really hurts to.
Yeah, you absolutely should have. If performance is one of your features of the code that you're writing, if it is a first class feature of your code, then I think it's useful to have benchmarks as basically, at that point, it's basically like a unit test, right? Like you're making sure that you're not losing that performance when you change the code.
But then that's not necessarily. I mean, your benchmark ends up becoming like an expectation, right, of the API.
Yeah, but benchmarks are I don't know. I don't.
Right.
It's not just that. It's just that when you see a benchmark, usually you see a benchmark along with some other library. And when you're dealing with a high-performance math library, the sample size is just so low that you can't really reliably compare libraries with these simple, high-performance, probably, optimized SIMD instructions.
To be clear, that's not what I meant at all.
Ago. Oh, I know. I'm just stating the fact that
Yeah, I got you.
Yeah, I remember, Jace, when we were trying to write that benchmarker. You have to deal with all these things when dealing with such a small sample size. I mean, it's pretty much up to the hardware.
Right. I mean, it's basically it's a royal pain trying to benchmark the individual math operations in a math library, because ideally they take so little time that it vanishes in the noise, but that makes them really hard to benchmark.
Yep.
Right. Absolutely.
So yeah.
So we're out of time. Thanks for the great conversations on today's topics. Next week, I was going to plan on doing a detour in quick prototyping UIs using LTK, just because again, that's I use LTK quite a bit when I need to write a quick UI, and I think folks need to be aware that if you don't want to go down the route of learning, say, Common Qt and until McClim, tells us that we can.
Becomes a thing.
Yeah, becomes a thing. You need to have a way to be able to show off your stuff, and LTK does do its job, and it does it well. And it works actually surprisingly on every platform I've used with it, including Windows. So that kind of gives it another thumbs up in my opinion. So so next week we're going to be talking about LTK. I'll show a couple of dumb examples on how to leverage it and how to use it.
God, it's been years since I've used TK for anything.
I know, but it's good, man. All right, it's good.
I never even used
works.
TK from Lisp. I have only used it from Python, and that was years ago.
It works. It works fairly well. It does what it's supposed to do. I can't complain too much about for what I use it for. I'm not going to say it has everything under the sun compared to some of the more full-featured libraries, but I'll show you what it has, and then hopefully you guys can reach your own opinion. After that, I'm looking for topics. So folks, as usual, I'm on Discord, I'm on IRC, and I'm on Functional Programming Slack. So drop by, give a comment, let me know if there's something in particular you guys want to talk about. I have a couple of ideas that I'm going to keep in mind in terms of planning, but as they come closer, I'll let you guys know. That's about it. I will talk to you guys later.
Bye then.
See ya.
Thank you.
See ya.